Well, bam. Hello. Hi, everyone. Good morning or afternoon, evening, wherever you are. Today is an exciting day. We have another coding battle today, and we have freaking Kami Creed here. Kami Creed, can you please introduce yourself, please?
Yeah, I'm Kami Creed, also Isogami Kumika. And yeah, excited but nervous. We'll see. We can do this.
Yeah.
I'm currently a PhD student in computer science. So, I mean, I don't know that reflects to coding speed or anything like that, but we'll see.
Mm-hmm. Oh, yeah. What are you doing in your PhD research now? You told me something about satellites and salmon counting.
Yeah. So yeah, it's basically like Starlink kind of thing, like with the low Earth orbit satellites, and also doing an automated salmon counting project that is kind of tied into that, since the river sides need like don't have in-network infrastructure, and so they need some kind of network for me to do this kind of automated counting and cloud-based thing.
Oh,
And
wait.
yeah, so
How the heck
put
do you
like a
count
Starlink there.
salmon like that?
Yeah, well, basically deep learning, like computer vision. They have an underwater camera, and you track the fish, and as they swim across, you can like figure out where they located, what the species, and then you can track them across multiple frames and count them in that way.
Oh, sick. This is all computer vision?
Yeah, computer vision stuff.
Oh, how do you tell if you hadn't count the same one twice?
Uh, well, you know, it does use a tracking algorithm that basically figures out whether this bounding box is the same fish or not, and so that's how
Hmm.
you can figure out multiple frames. But sometimes it can make mistakes, and that's one
Hmm.
of the research parts I'm doing, trying to improve that, and make it so that sometimes it might get the wrong species as well, since
Oh,
it's basically just a training algorithm.
I see.
Or
Very
yeah,
cool.
training the deep learning model.
Oh, what coding language do you guys use for this? Like Python?
Yeah, usually Python. Most machine learning uses Python to like, since it's not doesn't need like very what do you call, like very
Speedy,
like
fast.
low language, like very like memory based. Like
Oh,
it's not run on a, like a embedded hardware or anything like that. It's usually run on a big like multi GPU server, and
mm,
usually the optimization is with the training part, the
I
internals,
see.
and usually when you're like just trying to put in the training data and stuff like that, you just use Python to do that. So
I see.
yeah,
Yeah, Python, from what I hear, is mostly used for AI ML, even though it's
yeah,
like considered a relatively slow language. All the libraries are there though. So,
yeah, for sure. But there's libraries that C++ libraries that help with that make
mhm,
that a little bit faster
I see.
for specific parts. Yeah.
Oh, very cool. Oh, can you talk more about the satellite part? What do you guys do for that?
I mostly I've only recently just published like a measurement paper on that, like trying
Oh,
to figure
sick.
out all of the insights and stuff. And it's mostly currently still ongoing research, trying to like think of potential ways to improve, like since the current network like TCP and stuff like that are more for like terrestrial networks, not like satellite networks
Hmm.
specifically. Like it will work obviously, but like there could be some improvements because satellites um, often they will have to the satellite dish needs to switch between satellites
Hmm.
as the satellites move over. Since what Starlink uses is low Earth orbit satellites, which are really close to Earth, and so there needs to be a
Hmm.
ton of satellites, as they call it, a
Mm.
satellite constellation. And
Hmm.
so it needs to switch satellites a lot, and that like small like
Oh,
couple milliseconds, like that the handover is can be affect the network speed and latency. So that
mm.
needs to be figured out on trying to improve different like congestion kind of control algorithms for networking.
Oh, so it's like the problem statement, you're trying to develop a new communication protocol, like a whole new one to try to like get these
Maybe
clusters
not a
of
whole
satellite
new
to
one, but
work.
like trying to build on some other ones to try and make it more for satellites, basically more for these low Earth orbit satellites.
Oh,
That's
okay.
yeah, yeah.
I see. Very cool. All right. Uh, cool. Let's create a room for lead coding then. Can you see my screen? I should be sharing it on
Yeah,
Discord as
I can
well.
see it.
Okay. I've turned off, let's turn off the hard and medium questions like we usually do.
I see.
And then I'm going to deselect most of these. So we're going to select problem types that we think we can do. Usually we turn on like less than half of these because I don't know. I don't know garbage and you're pretty new too. Let's see. Yeah, I'm just going to scroll through really slowly. Let me know if you see any concepts that you're familiar with or if I click anything that you aren't familiar with. Yes, please no bit problems. I hate bit problems.
Yeah, bit problems are kind of it's pretty low
I think I
level.
know breadth first search. I don't know what these things are. I know how to count. Oh.
Counting, no way.
One, two, three.
It's like that. It's
Mm.
like that one song with the counting.
Wait, which song?
Was it? How did it go? It's like a rapping song. I
I
don't.
don't know any counting rapping songs. One.
Oh no, it was a. Oh no, it's the quick maths one. Never mind. So it wasn't counting. It's the
Oh,
math.
oh, I know that.
Yeah, yeah, yeah.
Do do something like do do pum pum. I do quick maths.
Quick maths. Quick maths.
I think I know what a
Like
heap
one
is.
plus one is
Priority
two,
queue.
and like
Yeah.
something like that.
Wasn't he like a comedian? I swear he was faking that, right?
Was he? Was he reading? I mean,
Wait,
it's
or
not
was
really
he
matters if it's a
serious?
song, but like just a song. So like even whether it's serious or not.
Let's see. I don't know what monotonic stuff are. I do know what queues and stacks are though. I know what a queue is. I know what recursion is.
Phew.
Don't know what. And please no shell scripting. I don't know that. Sliding window, I've heard of it.
I mean, I've done shell script before.
Oh, you want to try that?
To do good amount. Sure, yes.
Nice. I know what a string is. I know how to sort a little
Oh,
tree.
there's a stack.
Oh, you want to use stack? Oh, there we go.
And
Stack.
stacks are literally the same as an array, but like just on top.
Mm,
Unless that's a different stack. I don't know how many different types of. No, I don't know.
okay. I'm just gonna scroll through these really slowly. Let me know if you're good with these.
Oh, games theory database. Mm. Yeah, I guess that seems fine.
Okay, cool. I'm gonna save the room settings, create room, and wait, let me make sure there's no bit problems occurring. Just have to, what's bigram? Okay, that's not a bit problem. That's good. Cool. I'm gonna send you the room code then. Well, bam.
Maybe then. Oh, uh, should probably hide this screen.
All right. Cool. Do you want to do the honors and do a countdown, and then we can start the clock, start coding? You can just do like 3, 2, 1, go.
So we like click on. Oh, okay. Okay. Alrighty then. Let's.
Mhm.
Alrighty then. I should probably bring up the timer first.
Oh, yeah, yeah. You should have a timer on your end too.
Yeah, got it. Alrighty then. 3, 2, 1, go.
Good luck. See ya.
Yeah, see ya.
All right, guys. Oh, we're alone together now. I'm using Java. Bam. Okay, here. Crawler log folder. Oh. All right. Leetcode 1598 crawler log folder. Ooh. The Leetcode file system keeps a log each time some user performs a change folder operation. Okay. So this is not the actual Leetcode website. This is like a operating system called Leetcode. The operations are described below. This moves to the parent folder, the current folder. If you're already in the main folder, remain in the same folder. This remain in the same folder. X/move to the child folder named X. Move to the child folder named X. Oh, okay. This folder is guaranteed to always exist. You are given a list of strings logs where logs I is the operation performed by the user at the ith step. The file system starts in the main folder, then the operations and logs are performed. Return the minimum number of operations needed to go back to the main folder after the change folder operations. Okay. Oh my goodness. Okay. Output is 2. Why? So you go to D1, D2, back to D1, D2 again. You stay in the same folder, I guess. And D2. So you just go 2 times back to the main folder. Okay, that makes sense. Example 2. I guess you do all this shtick up to folder 3, and then you can go back to main with three steps. D1. Okay, you go to D1. You go back to the main, back to the main, back to the main, so it's 0. Okay. Apparently there's a hint. Simulate the process, but don't move the pointer beyond the main folder. No, we have to simulate the process. Simulate the process, but don't move the pointer beyond the main folder. Beyond the main folder? Don't move the pointer beyond the main folder. Okay, how do we do this? We obviously need to... Uh-oh. How do we do this? D1, D2, D21, D21. All right. Huh. I'm thinking we use a stack. Okay. In my head, I'm thinking about using a stack first. So, whenever we move to a new folder, we put it into the stack. New folder, we put into the stack. Whenever we move backwards, we pop the folder from the stack. D21, we put into the stack. If it's this, we just don't move, right? Okay, and then in the end, we just see how many things are in the stack. Yeah, we just see how many things are in the stack, right? But that's not what the hint says. Simulate the process, but don't move the pointer beyond the main folder. Don't move the pointer beyond the main folder. What does that even mean? We have one pointer that's always pointing to the main folder. I don't understand that. I think my way works. We just use a stack and simulate the process. Yeah, in the end, we return how many things the stack contains. That's what I think. Okay, I'm gonna try that then. Here we go. D21. What happens if we try to move to the same folder? This folder is guaranteed to always exist. Okay, we don't need to worry about this then. Okay. You know what? Let's do this. So let's make a stack called what? The folder's literally called D21. Okay. Is suggesting a possible approach not allowed during the contest? Yeah, I prefer if you don't tell me what to do, because that might give me an unfair advantage against Kami Creed. Yeah. I think I'm gonna do a stack. Yeah, a stack. Do I need to parse? Okay, I'll think about all this during. I won't, I promise, just watching. Oh, thank you, I appreciate. Is equal to new stack. Am I even instantiating the stack correctly? Okay, so for every single string log in logs, we need to see what command it is. So let's try easy case, right? Let's add X, like a named folder, into it. Well, you know what? Let's start from the top. Maybe we can just do if it's this, else do that, because it can't be anything else. Okay. So if log dot equals move back in your directory. If you can move back, what do you do? Should we just do like a quick sanity check to make sure that we're even reading all this correctly? So I'm just going to print out move back. Move back. Else if log dot equals, stay the same. System.out.println stay, and else system.out.println move. Sure. Okay. And then we're going to return a bogus return value for now called -1. And let's just have a sanity check to see if we're even parsing everything correctly. Okay. So move back, move, stay. This sounds good, doesn't it? Yeah. Move, stay, move back. Yeah, I think we're parsing this correctly. Okay. Cool, very cool. Wait, is the stack even necessary at this point? Is it even useful to us to maintain a stack of this? Can we just maintain an integer count? Like this will be 1 and then 2. Move back will be 1 and then 2 again. 2. Wait, yeah, can we just do that? Is there a point to maintaining a stack using so much memory? I don't know. Is there? Okay, let's comment out the stack for a moment. Let's do an integer called depth is equal to 0. So if we are to move back, if the current depth is greater than 0, then depth minus minus. If log equals stay, then we just stay. If we move, then depth plus plus. And then in the end, you just return depth, I think. Am I underthinking this? This seems way too simple to be right. Well, apparently it works for the test cases. Let's remove all these print statements. Submit. I swear. Jesus. Oh, it works? Jesus, okay. Well, that was a surprise. I am 1-0. Alright. Heck yes. I'm so surprised that works. No stack needed. That's crazy. Occurrences after bigram. Given two strings, first and second. Consider... Wait, what? Given two strings, first and second. Consider occurrences in some text of the form first, second, third, where second comes immediately after first, and third comes immediately after second. Okay? Return an array of all the words third for each occurrence of first, second, third. Oh, hi Velveteen, I can't talk today. Hi Chet and chat. Hello, hello. I'm facing off against Kami Creed today. Wait, I don't understand this question. Given two strings first and second, consider occurrences first, second, third, where second comes immediately after first and third comes immediately after second. This seems... this whole chunk seems really redundant. But maybe it's important. Return an array of all the words third for each occurrence of first, second, third. Okay? 1, 2, 3. Wait, I don't get it. First, second, third. Given two strings. Oh, here. First is A, second is good. A, good. So we return girl. Girl, student. Huh. Wait. What is this? Return an array of all the words third for each occurrence. So our job is to detect the occurrence of these two things. And then return the string immediately after that. We rock. We will rock. Huh. Oh, okay. The first is we, second is will. We will. So we, and then we will rock. I see. So perhaps this is some sort of edge case here, because some people might skip the parsing of the second we, right? We will, okay. Oh, that's interesting. So I imagine every time we come across a we will have to check if there's a third. Yeah, we can't just skip the third once we parse it. Okay, I think I have an idea of what to do. We're going to go through the sentence through every single word. Every time we see the first word, we will see first if the second word exists. If it does, excuse me. If it does, return the third word if it exists. And put it into, no, not return it, put it into a list. Yeah, okay, I think that's what I'll do. I think that should work. Let me drink some water. My throat is dying for some reason. Okay, so iterating through all the words in text. This calls for some string splitting, does it not? String words is equal to new text dot split by space. I'm so paranoid if this splitting works. I've had some issues with it in the past, so I will do another sanity check. So words dot arrays.toString words, and then we will return null as a dummy value for now, and sanity check, here we go. Bam. Alice is a good girl. She is a good student. Okay, we are splitting it correctly. Very nice. Okay, what do we do from here? We need to iterate for every single word. For int I is equal to 0, I is less than words dot length I plus plus. Okay, what's the current word? String current word is equal to words I. Okay, and then for every single word, we need to check if the second exists from it. Well, first we need to check if it's equal to the first, right? If current word dot equals the first, okay, and then we need to check if the second exists. So if I plus 1 is still in bounds, is less than words dot length. Is this how we do it? And words I plus 1 is, equals the second. I am so paranoid if this works again. So we're doing if the current word is equal to the first and the second that follows is inbounds and the second is equal to the given second, then we do something. We need to check if the third is inbound too, right? Oh, this is getting kind of complicated. If I plus 2 is also less than words dot length and, well, ooh, am I doing this right? And then let's do a sanity check. We like sanity checks, don't we? Let's just print out what the third word is, apparently. Words I plus 1. No, I plus 2. I'm going to do third. Okay, let's see how close we are. Girlston, oh, I think we got it. We rock. You know what? I think we got it. Is this bad when on runtime? For every word we check up to 3 words. Wait, no, it's still end time, right? Because that's constant. The 3 is not dependent on the size of the inputs. So we should be fine. Okay. Man, I feel kind of bad. I'm going to go 2-0 if I solve this. Hopefully Kami Creed gets something soon. Should I check out how Kami Creed is doing? Twitch. Kami Creed. Oh, he got it. Let's go. Oh, never mind.
What?
Okay. Well, he's on the right track, so I feel less bad about submitting. Okay, what do we do here, though? We need a list to store our answers in. So list Let's not do an array right off the bat because we don't know how many there are, and Java arrays are annoying in that there's no fixed size. Oh, look, he has been submitting. Ooh, things are getting exciting. He submitted like 4 times. Hopefully he's not like super panicking. String result is equal to new array list results. Okay, so every time we find a third, results.add words I plus 2. Man, that's so interesting. So he apparently got accepted in the he got the base cases passing, but not the submission cases. That's kind of weird. Okay. Okay, how do I convert a... Let me just pause this stream, yeah. In Java, how do I convert a list to array? Please don't tell me I have to copy everything. List.to, oh, that's easy. List.to array, I can just pass in Okay, just list.to array, huh? Okay, what do I do here? String list results array is equal to results.to array. Is that what I do? To array. Do I have to put a do I have to put the size of the array? That's kind of inconvenient. Storing it inside array of strings. Okay. List.to array new strings. Okay. Results.to array. Wait, that's so inconvenient. So I have to make a new, literally new array myself. Okay. So I have to do a new string list with size results.size. Man, list to array conversion is annoying. List.to array. Should I do another sanity check if it works? System.out.println arrays.to string results a. Run. Hopefully it works. Oh, girl student. Very good. We rock. You know, I think we got it. We just have to return this now. Results a. And it works. How's Kami Creek doing? Krishna says, can't we just call results.to array? Really? From the Stack Overflow articles I read, you need to pass a size in. Wait, let me get up. Java list.to array. Oh my goodness, really? Cars. Are you kidding? We can just do that. I did all that work for nothing. Cannot be converted to a string. Oh, do we have to cast it? This is a string array, Java. Put your puck says, no Googling allowed. Yes, Googling allowed. We can Google and ChatGPT as long as we don't look up the actual answer. You know, just like an actual interview. Well, some interviews don't allow ChatGPT, but I rarely use it. Cannot be cast. Why? Why? Cars.toArray. You know what? I'm not gonna think too hard about this. I'm just gonna submit this. There we go. Hey, it worked. Woo. So Krishna says, my bad, it returns an array of objects. Oh, yeah, that's fine. I appreciate you trying to help. Oh wait, hold on. Don't help me. It gives me an unfair advantage. How's this guy doing? Occurrences after bigram. All right, go Kami.
Don't remember substring.
I guess he switched to the next problem, I guess. Range sum query. Immutable. Oh no, what is this? Okay. I can kind of calm down for now because I'm kind of safe in the lead right now. Range sum query immutable. Given an integer array nums, handle multiple queries of the following type. What? We have to design queries? Calculate the sum of the elements of nums between indices left and right. Inclusive, where left is less than the right. Sounds like prefix sums. Implement the num array class. Initialize the object with the integer array nums. Okay. In sum range left right returns the sum of the elements nums between indices left and right inclusive. Yeah, is this not prefix sums? We calculate the cumulative sum at each index. Yeah. And then for each sum range, we can, this prefix sum minus this prefix sum at here. Sum range takes indices, right? Yeah. I feel like we can just do prefix sums. Hold on. Let me make sure I'm not being an idiot right now. Let me make sure prefix sum actually works. Okay. What would be the prefix sums here? -2, -2, 1, -4. Kind of messy, but okay. Did I do this right? -2, 0, -2 plus 3, 4, 2, 1. Okay. The sum range from 0 to 2 is 1, 0, 1, 2, 1. Oh, this doesn't work. Hold on. Wait, no, it does work. 0 to 2. 1 minus Nothing. Yeah, just 1. Okay. 2 to 5. 0, 1, 2, 3, 4, 5. So 1, 0, 1, 1, 3. Uh-oh. Wait, does it not work? 2 to 5. 0, 1, 2. We start here. 3, 4, 5. 0, 1, 2. Negative 2. Negative 2. 0. Negative 1. So it's negative 1. 1. Huh. Uh-oh. Is the math not working out here? I thought we can just do 1 minus negative 2. But that's 3. Oh, math's not working out. Am I not doing this right? Negative 2. Am I not taking the cube sum correctly? Negative 2. Oh no, negative 2 plus 3 is 1. 1 minus 5 is negative 4. 2. 2 minus 1 is 1. 0, 1, 2. Wait. Range 2 to 5. Inclusive. 0, 1, 2. 0, 1, 2 is 1. Okay. So the first one we got, y is 2 to 5. 0, 1, 2. 3, 4, 5. Negative 1, yeah, okay. Uh-oh. Does prefix sums not work for here? No. Oh, he solved the current interceptor diagram. Hey, let's go. You solved the diagram one. Woo.
Yeah, first try. Crazy.
First try. Yeah. I saw you submit a lot for the first problem. Did you give up on that?
Yeah. I kind of, I guess. It's kind of, I don't
I
know.
see.
Slash. I was trying to like do different things, but then it didn't work.
I see. I was watching your stream a little. Apparently you got all the basic test cases down, but the submissions were getting you.
Yeah, basically.
Huh. That is so weird. Sometimes it does that.
Yeah, I don't
There's
know.
hidden test cases.
Might
Oh,
come back
good
to that
luck.
later. Yeah.
See you later.
You too. Bye.
All right. Wait, I'm actually so stumped. Does prefix sums not actually work here? Or am I just tripping? 0, 5, 0, 1, 2, 3, 4, 5 is 1. Zero, 5 is negative 3 here. Okay, let me read the explanation. Okay, here. Return negative 2 plus 0 plus 3 equals 1. 2, 5. 0, 1, 2, so return 3 plus negative 5 plus 2, negative 1 is 1. Zero to 5, return everything added together. Zero to 5. Hold on. Did I not add these correctly? Negative 2 plus 0 is negative 2. Negative 2 plus 3 is 1. 1 minus 5 is negative 4. Negative 4 plus 2 is 2. 2 minus 1 is 1. I don't get it. Negative 2 plus 0 is negative 2, plus 3 is 1, minus 5 is negative 4, plus 2 is 2, minus 1. Krishna says it's negative 2. Am I just not mathing right now? Negative 2 plus 0 is negative 2. Negative 2 plus 3 is 3. 1 minus 5 is negative 4. Negative 4 plus... Oh, you're so right. Thank you. I'm actually not mathing. Negative 3. Holy. Well, that's embarrassing. Thank you so much. So here, negative 3. Negative 3 minus 2 is minus negative 2 is 1. Okay, that maths out. Okay, prefix sums it is. Thank you, Krishna. I appreciate it. No, I got help. Thank you. Okay, prefix sums, here we go. Prefix sums. Prefix sums is equal to new nums with the same length as, new int array with the same length as nums dot length. Okay, and we just add up all the numbers. Sum is equal to 0. For loop, int I is equal to 0. I is less than nums dot length I plus plus. Sum plus equals nums I, and then we update that into prefix sums. Prefix sums I is equal to the current sum. Let's do a sanity check after this too. Arrays dot toString prefix sums. Let's return bogus value -1 for now. Yeah, let's make sure we have our prefix sums array correct. Sanity check. -2, -2, 1, -4, -2, -3. Perfect, okay. That is good. So here I just return what I return. Right? Cumulative sum is equal to prefix sums, right? Okay, we gotta be careful here because if left is out of bounds, then we're kind of screwed. So int left cum sum is equal to, so if left is equal to 0, then we return 0. Yeah, else we return, wait, if it's less than or equal to 0, let's be extra safe. If it's less than or equal to 0, then we return 0, else we return prefix sums left -1. Yeah, that should be it. And then return right cum sum minus left cum sum. I feel like that's it. Hey, it worked. Let's go. Okay, I feel kind of bad if I go up 3-0. How's he doing? Sum plus equals. Okay, so he's doing the linear method. He's not pre-computing anything. Okay. That's probably fine, to be honest. Unless he runs into a timeout issue. He submitted. Is he gonna do it? Well, okay. Well, go Kami. Submit. Let's go. Whoa. Oh my god. Yo, we solved it at the same time, bruh. Jesus.
Oh yeah, wow, okay, I didn't notice that.
That's pretty wild. See ya.
Interesting. See, yeah.
Wow. Did the linear method actually work? Dang. And I was thinking for so long on the other one. An array tree pre-order traversal. Okay, there's 19 minutes left. It's kind of iffy if we'll be able to solve this one, but I'll give it my best shot. Given the root of an n-array tree, return the pre-order traversal of its nodes values. Huh, the pre-order traversal. What does that mean again? Is it the left? I forgot the order. N-array tree input serialization is represented in their... Huh? We have to return it in a list. N-array tree input serialization is represented in their level order traversal. Each group of children is separated by the null value. Okay, so yes, this is a row level 1 null, 3 2 4 null, 5 6. Pre-order is then 1 3. Okay, so it looks to me like pre-order is the root 1 3 left right, root left right, 1 3 5 6. Okay, and then 2 4. That is how. How the frick do we do this? No. Wait, did I get that right? Is pre-order left? No, root left right. What is pre-order traversal? I'm just making sure that's actually root left right. Root left right. Okay. Fantastic. Root left right. Oh man. Root left right. Oh no. So I go from 1, which is here. This is the format of the tree that I'm given. 1, 3, 5, 6, 2. Oh no. How? So I'm given this. I go 1, 2. Oh, this is so complicated. Can I literally just reconstruct the tree? Pre-order traversal to nodes. Wait, in the tree that they gave me. Wait. This is not that bad. Wait. They gave me, oh my goodness. They gave me the nodes. It's not in the it's not in the form of a list. I'm dumb. Holy crud. Okay, so what we can do is literally pre-order traversal recursive, right? Okay. Let's try a basic pre-order traversal. ln. Wow. I thought they were giving me a list the entire time. They were giving me a node. God damn. The root dot value, sure. And then pre-order root dot left, pre-order root dot right, and then return. Sure, let's return null for a sanity check. This should work, right? Cannot find simple root dot left. Oh. Oh. It's for every, there's no, this is not a binary tree. Yeah, thanks, Krishna. For every single node child in root.children, then you do the pre-order on them. Pre-order on the child. If this works, we will know. Okay. 135624. Yeah, wait. The 1310. We got it, boys. We got the order down. Okay. We need to store all this in a list now. I propose a helper function where the list is stored in the parameter so we have a better time of manipulating it. Private helper. Let's do void helper node root and then a list of integer result. Oh man. And then we basically just copy this in, except instead of printing it in the result, we add, yeah, we added to the result the root.value. Root.value. Heck yes, okay. And then over here, we just do a new list. List integer result is equal to new array list, I guess. And then we just do the helper where we plug in the root and then the result. And then we return the result. I feel like this looks like stupidly simple. There has to be something I missed, right? Null cases? I don't know. I'll just run this. Wrong answer. Output is 1. Oh, why is it just 1? No. Oh. I'm calling the wrong function. Pre-order child result. Oh. I thought I called my helper function the same thing. It's not. Let's go. Hey. There's 11 minutes left. If I just for him right now, or for to him right now, I don't know. I feel bad about getting off for it when there's 10 minutes left. Is this ethical? Hmm. Null case. Uh, oh, concrete submitted. Constraints say, what does the constraint say? Oh, this is exciting. Kami submitted. Okay, because you could have zero values. Okay. So if root is equal to null, I guess, just return. Kami submitted. Yo! Hey, let's go. You solved it.
Yeah. Second submission, so not a
God,
thing.
God damn it. All right, I'm still working on it. I swear I will catch up.
I still
See
need
ya.
to do that to this one. So yeah, see ya.
See ya. Submit, boy. Come on. Yeah. Yo. Yeah. Okay, but Kamikreet still, he still has a chance of tying me.
Wow,
He literally,
congrats.
hey, oh my God. Oh, thank you. Wow, that was a
Yeah.
miracle.
It's probably due to how bad I did this first question. It's like I tried to like hack it and stuff like that.
Well, yeah, do you want to show how you're trying to do the first question? Or actually, do you want to continue and try to tie me or
Time. What do you say?
oh, do you want to try to solve the first one or
Uh,
no?
guess. Let me see. It might
You
just
could
be
try to
the
like
time.
tie the score. That would be pretty exciting.
But isn't it already tie the score? Oh, but I guess you already finished it faster.
Oh, okay. Never mind then. Yeah. Do you want to show your code anyways? Maybe we can try to figure out what you're like doing
Yeah, I've been
in the
looking
first
at
one.
let's see.
Oh, I'm watching your screen, your stream, by the way.
Oh,
Uh, oh, okay. Let's
yeah.
see.
It's a little
For log and logs. Okay, so yeah, that's basically what I did so far. You're parsing every string in the logs. If it's equal to, hmm,
yeah. I think it's the how it goes into a parent folder, at least for default, is a little bit weird. I don't know if I'm able to use pathlib, so could use that would be better probably.
oh, okay. Wait, actually, I kind of battled with this too. I was trying to maintain like the actual, like, I don't know, entire file path with like a stack. But then I found out that um, there's no need to like maintain like what do you call it? The current list of your current folders in any way. You can just do a
Mm.
count. Like every time you enter a folder,
Oh, that's
add
true.
to the count. Every time you go back, minus the count. Every time you stay, you keep the count the same. Like there's no advantage to
Right. I forgot about
storing the current file, file string.
that. Probably.
That could be a really quick change for you. Yo, you could tie
Yeah.
me. Holy crud.
Hmm? Let's see.
Yeah, dude, I was battling this for I was trying to do a whole stack, trying to store all the folders I'm into, and then popping the folders when, I go backwards and stuff.
Yeah.
Oh, you're almost there. Uh,
Oh,
is it because you're
okay.
going backwards when you? Oh, yeah. It's because you're going backwards too much, maybe. When you're at the home folder, you just stay at the home folder, I guess. Like, um, yeah. Uh, oh wait, no, no. You can like do like if your count is already zero, just like cap it at zero. Like if your count is equal to zero, that means that you're at your home folder, right? So only decrement the count if it's greater than zero, I guess. That was my thinking.
Right.
Oh, never mind, you got it.
Okay, nice.
Hey, let's go. Yo.
Yeah. What are these magic skills you're casting? Hello, Murray. Oh, I wasn't even watching chat. Oh, well.
Hey, let's go.
Yeah.
All right,
We
it's a
did it.
tie then. I'll count as a tie.
You count as a tie. It's like 4 minutes off.
Hey, that's pretty nice. How did you like that?
Yeah, not too bad to be honest.
Yeah, I thought you did
Yeah.
pretty well. I think you're the second person to complete the entire all the battles
Oh,
I've done.
really?
Yeah, that's
Only
pretty
two?
good.
Interesting. Did you do like 8 or something?
I've
Or
done,
oh no, I
yeah,
guess
I've
like okay.
well, yeah, I think I've done 8 battles so far. The other person who completed the room was Nerino, who's the real Nasdaq data analyst. I think that was his job.
Mm,
Yeah.
right.
Um, yeah, some people come really close too. I think Circuit,
Mm,
the CS major, got three, and then Sunzalor, who's the LLM researcher, got three. Oh yeah, because we got a
mm.
bit problem in that battle too.
Problem.
None
Oh, I
of
see.
none of us knew how to
You're
do
supposed that you didn't get
it.
it.
Yeah, we were so screwed. Actually, he technically would have won. He was like way ahead of me, like
Ah,
few minutes ahead of me, and then we both just got clogged on the pitfall. So in a way, it kind of
sounds
saved
about
me.
right.
It
Sounds
ended up
about
in a
right.
tie too. Mm.
Phew. Yeah, that was fun.
Yeah,
Yeah, yeah. Not a bad introduction to Leetcode, to
yeah.
be honest.
Oh, yeah. All right. Let's see. You're a PhD student, right? Like, what are your,
Mm.
do you have to like, are you planning to go more into research or do you want to go into engineering roles too?
Yeah, I'm thinking like even though I'm doing like the research and stuff right now, I'm not sure if like continuing the research is for me that much. I might like after graduation probably consider going back to industry, like to software engineering or maybe even something like research and engineering, I guess.
Oh, okay.
Like that salmon project I was talking about, they could hire me in some kind of commercial thing that they're trying to thinking of doing with my system. Um,
Oh,
so
that's
it'll
pretty
probably be
cool.
mostly like research and like maybe a bit of management in that, I guess, role.
Oh,
That would be kind
management.
of nice. Yeah.
Oh,
But
interesting.
I guess I do like coding stuff a little bit more than research, to be honest. Like writing the
Mm.
papers.
Do you
It's a little,
enjoy like the coding part more than the research part?
yeah, I think that's the case.
I see. Very cool. Oh
Yeah,
yeah,
because
you
like
said that you worked
research,
as a,
lots of
oh, sorry,
papers.
go
Yeah.
ahead. Mhm.
Yeah, yeah. I was just saying that the research obviously you need to read lots of papers and then like basically take those papers and have your related work section and try to build your own paper based on other works and obviously do your experiments on certain ideas that you might come up with, like maybe combining certain algorithms or something like that. Like that
Hmm.
part, I guess the it's kind of hard to get into like the reading all these papers, especially like you don't have time to read everything in detail, so it's kind of a like a grind in a sense. But yeah,
Hmm.
yeah.
Oh, I
So
see.
Juver, it's asking what college do you guys go to? I don't know if I should say my actual college, but or university. So sorry about that.
Oh, I can tell you what college I currently go to. I go to no college because I already graduated. Oh, checkmate.
Yeah. Oh wow. No way. But
Take
yep,
that.
something ringing. Oh,
Is it your...
it's the timer, isn't it? Oh,
Oh,
it's the
your
timer.
timer.
That's what's ringing.
Yeah. Dang, we actually completed this so early. Usually we're coding all the way up to the clock ends.
Really? Oh, I see.
Yeah.
I mean, if the bit problem comes up, I can see that.
Yeah, if the bit problem comes up. Hmm. Oh yeah, you said that you worked as a software engineer before, right? Before your PhD. What was that like?
Yeah, so it was actually it's kind of a startup company, and
Hmm.
it's kind of like one of the professors at my university started up that company, and it was more of a I went into that as a co-op first. I was still an undergrad, and I decided to do a co-op semester.
Hmm. Wait, what's a
And
co-op
they
semester?
oh co-op is like intern basically, just like a
Uh,
semester where you're working for. You can choose how long you want to work. Usually, sometimes there's like people work for 8 months, like 2 semesters, instead of 4 months, which is one semester.
oh.
So yeah, but I only worked the co-op for one semester, but
Hmm.
because I wanted to graduate first, and so I worked at that startup as an intern for a semester, and then I continued my school, and then actually did part time at that same uh, job, I guess. And then
Oh.
once I graduated, I did like a year full time at that software engineer job.
Dang,
Which,
they must have really liked you to keep wanting you back over and over.
yeah, I guess so. It's actually quite the experience if you work at a startup because you have like so many responsibilities. Since
Uh-huh.
like they don't obviously have the capacity to like hire a ton of other software or programmers, and so you're
Hmm.
doing a little bit more in certain places. Um, like you might need to jump, like have like, multiple projects sometimes,
Hmm.
uh, and so it's quite the experience working at a startup.
Oh.
Uh,
Are you allowed to say what the startup does?
yeah, like base in like what they already say is basically it's started more I guess more of an AI thing. Like they did
Oh, shoot.
some computer vision stuff as well.
Oh.
Um, I think they started yeah like they didn't go into deep learning until later, and now I think they're doing more fall detection. They're for seniors. They detect
Oh.
whether they seniors fall and through like a camera or a sensor. I think maybe they were looking into like other ways instead of a camera. I'm not sure, infrared sensors or something like that, so that you can like keep their privacy.
Dang.
And so yeah, basically fall detection, and they have an app where they like notify probably the children or a caretaker that the senior has fallen and maybe they need help. Or I think their product also like might have a mic that you can like connect to like ask, oh, are you okay, do you need help, should I call
Hmm.
911 kind of thing. So
Oh, I see.
that's like their product that they're working on.
I imagine that's like kind of like a backup for false alarms, I guess. The false alarms are gonna be crazy,
Yeah,
aren't they?
yeah, for sure. I
Like, what if they're
mean,
just
yeah, it's a
uh
bit of
I don't know, what if they're just crouching down? It's like someone has fallen.
It could be
Call the
possible. I
cops.
mean, it depends on how good they're training for the train how they good they train their model. Usually, deep learning is not too bad. For train if you have like good data, like lots of good data for that. I technically I wasn't part of the training for that. I was mostly the software engineering like kind of worked on various things and helped with the app a little bit.
Hmm.
I guess my role was mostly doing automated builds,
Oh.
doing working on trying to automatically like compile the software, like they're using like C++ or like they have their own like build to try and compile it and then test it, and that's like
Hmm.
my part trying to automate that using like scripts
Oh.
and I think we were using some tools that you could
Oh.
like write a lot of ways to connect them to different to like server computers that we have in house to run
Hmm.
that automatically when someone pushes to GitHub, for example.
Mm. Is that
Yeah,
what they call DevOps? I think that was TJ's job too.
DevOps.
Like,
Yeah, I guess DevOps.
I think it's like doing
Like
everything
some
but the actual
I've also
product.
I guess since I had so many responsibilities, like the build system, and then I also had to manage some of the server as well. So I'm a bit of sysadmin as well. So it's just a lot of
Mm.
different things. Even though my title is just software engineer, I did a lot of different things in that startup.
I see.
Yeah.
Hmm. All right. Very cool. Do you have anything you want to plug at the end before we drop off?
Well, I
Any
guess
stuff coming up?
just yeah, just my YouTube, Twitch is the same comic creed, and yeah, I do mostly gaming stuff, I guess. Like I'm actually planning probably planning with some other people doing Lethal Company. I think that's November 21st. It might not be fully done yet, but I'll probably put up a scheduled YouTube event when that's finalized. And yeah, also, well, I've only done one karaoke stream, but I want to try to do some more self karaoke streams, and also join Prime TV's
Yeah.
karaoke. Probably join again tomorrow. We'll see.
Mm.
But yeah, that's me.
Hey,
Yeah,
very cool. Well, thank you. Was it Kumika, your other name, Kumika?
yeah, Kumika. Yeah, I
Okay.
don't mind calling Kumika.
Oh, cool. Thank you, Kumika or Kami Creed, for joining us today then. That was a pretty cool battle. 4-4. We don't see a score like that very often. Yeah,
Yeah,
thank you so much for coming. Thank
yeah.
you everyone
Thanks
for
for having
joining as
me.
well. Yeah, this was very fun. See you next time then.
Yeah, see ya.
Bye.
Bye
Thanks so much.
bye.
Oh, that was crazy, guys. Oh, that guy was a real PhD person, PhD candidate. 4-4. Oh, this is gonna be an exciting edit. Jesus. I've gotten so much like, I don't know, 3 guests so far have gotten scores of 0. So it's like almost unbelievable that one gets like a full score. Jesus. All right, that was fun. Um, I have nothing else. I think I'll just end the stream. Thank you, Kami Creed, for for being willing to do this. Shine us with your grace of your PhD brain and your interesting experiences. Yeah, that's it for now. Bye, guys. That's it. See ya. See ya Monday. Bye.